video, but I got a phone call and I thought I was pausing, but in fact I just stopped it. So my mistake. Anyhow, back to this whole problem. We've got a complete raw free body diagram. Now we've got to pick our coordinate axes. So I'm just going to use the standard axes. We're accelerating upward here, right? So we're perfectly fine to go like this and go X and Y like that. And so, of course, down here we'll go X and Y. Since our two forces both act along one of the primary axes, we don't need to do a separate diagram with the components. We can just skip directly to sum of forces in the X direction, which is nothing. And that equals mass times acceleration in the X direction. Yippity-doo. So, sum of forces in the Y direction. Now, this, of course, is a little more involved because there is a force in the Y direction, which is tension, and there is another force in the Y direction, which is gravity. And that's going to equal our mass times our Y component of acceleration. And so now the question is, what is that Y component of acceleration? Well, they're accelerating as they go through this circular swing like this, they're accelerating upwards towards the center of the circle. So acceleration in the Y direction is equal to, in fact, their centripetal acceleration. Okay. So, and that was 5 meters per second squared. So now what we want to do is take this. We want to find the tension the rope has to be able to stand. So Ft is going to equal, we're just going to bring the mg over, mg plus m times their centripetal acceleration, which we already found. You could plug in v squared over r there if you wanted. For some reason I did the numbers first. I don't know why. So, what's that? Okay. So Ft is the mass of g plus centripetal acceleration, and I said in this case the mass, well, let's see, the mass here is the mass of Luke and Leia together, which is 120.0 kilograms. Okay, so, whoops, sorry, equals 120.0 kilograms. G on the Death Star is 10.0 meters per second squared, and the centripetal acceleration is 5.0 meters per second squared. So that's going to be 15 meters per second squared times 120 kilograms, which is going to be 1,800 newtons. And that is the tension the cable has to be able to handle. There you go. And on to the next problem.